All right, hi guys. Today's little conversation we're going to have is to do with parallel circuits. We did an online session this morning. I just wanted to quickly review a few of the notes that we had maybe had come out of that. Do one or two example problems on the board here fairly quick, just to ensure you have a good understanding of what's going on with parallel circuits. Now, first off, we can review the rules of parallel circuits. So the rules of parallel circuits and series circuits, if we put those over here, we've got parallel versus series rules. Now if we think about a series circuit, we knew that the total resistance was the sum of adding up R1 plus R2. So R total is equal to R1 plus R2 plus R3 and so on and so forth. All right? Now, another rule with series circuits was that the sum of the voltage drops, in other words, V1 and V2, had to equal E total. All right? So we wrote that again over here. E total is equal to V1 plus V2 plus V3 and so on and so forth. Current within a series circuit stays the same throughout, and it is being driven by, the amount of current is being driven by the amount of resistance and the loaded or the source it is connected to. So if we wanted to put a rule down for what that is, we would say I total is equal to I1, which is equal to I2, which is equal to I3, and so on and so forth. Okay? And then once we worked out our powers, we knew that we could add up all of them to get our power total. Okay, so that's your series. Now parallel circuits start a little opposite of that in some regards. Okay, what is a parallel circuit? It is a circuit that has more than one branch for current to flow through. Here I've just drawn two branches for current to flow through in parallel. What are they meaning by in parallel? It means that the load, each load is connected directly to the source. There is no further resistance in series with that load at this point in time. Okay? So whatever voltage was at the source will be the same voltage here and be the same voltage there. So this is R1, this is R2. Okay? So a quick rule, or one of the first rules we can look at, would be E total is equal to V1, which is equal to V2, which is equal to V3, and that won't change. So the source, whatever the source voltage is, will be the same at each of those branches. Okay? Now my resistance is, here and here, are going to dictate how much current flows at each of those lines. Okay? We have a line current here, I'll call that I line, otherwise known as I total. Okay? The current leaving there is going to then separate and come down separately into each of those branches. Okay? And then this current is going to head down here and eventually come back this way, join up back together and return home. Very important to know that whatever current leaves the source has to come back. We cannot create extra current within there, okay, or we can't have some leave, okay? It all has to, whatever is leaving has to come back. It never changes. Where it does change is the individual current within each branch here, okay? So if I wrote a rule for current, I could say my I total is equal to I1, which is equal to I2, which is equal to I3, dot, dot, dot. Nope, did I get that right? That's wrong, okay? We add them together, don't we? So there's the big difference between series and parallel right there. Okay? Now, Power totals, I'm leaving resistance for last because we'll talk about that in a minute. Power totals is the same for series and in parallel. We can always add them all up. Now, if I gave us an example here of 100 volts, okay, and each of these resistors were 10 ohms, okay, I know that I've also got a V1 of 100 volts and a V2 of 100 volts. Now that doesn't mean 100 plus 100 equals 200, no. Remind us of our rules, V1 equals V2 equals V3. So now that I've got that, 100 volts divided by 10 ohms will give me a current up here of 10 amps. Same over here. All right, so we've got 10 there and 10 there, meaning that my line current here is 20 amps. Okay, I'm just mapping the current out here so you can see how it flows within the circuit. This is 10 here. Okay, so we started with 20. We need 10 this way because of that load, and we need 10 here because of that load, so the 20 becomes 10 and 10. These 10s join back together to give us the 20 again. Okay, so that's how current flows within a parallel circuit. All right, we could figure out our powers by going 100 times 10 to give us 1,000, 100 times 10 to give us 1,000, or we could also confirm it with our totals, 100 volts times 20 to give us 2,000. In other words, 1,000 watts plus 1,000 watts gives us 2,000. Okay, so far so good. Lastly would be our R total. Now, simple way of doing it using the totals, R total is equal to E total divided by I total. So in other words, we could go 100 volts divided by 20 amps to give us 5 ohms. All right? Or in your textbook, they also give us an equation. 1 over R total is equal to the reciprocal of R1 plus the reciprocal of R2. Okay? So if we did 1 over 10 plus 1 over 10 equals 1 over R total, you would find that you end up here with that's 0.1 plus 0.1 giving us 0.2. But then we need to do the reciprocal of that, and that should come out to 5 ohms. The resistance in total has to be lower than each individual branch resistance. That will always be the smallest number, that 5 ohms there. Ohm's law in the totals can prove it, or if we didn't know any other information and we were just asked to find the total resistance and all they'd given us was resistors, we could use the reciprocal equation here. So if I put that up top, 1 over R total is equal to 1 over R1 plus 1 over R2 plus 1 over R3, and so on and so forth. Okay? So that tends to be the hardest one for people to get straight. They immediately always want to add up 10 plus 10 giving you 20. But if you were to do that, 20 divided by 100 will tell me that we only had 5 amps here, and that would not even be sufficient or enough to be able to handle what the loads are requiring. Okay? I tend to not use this formula a lot. I like to pick it apart and then work on the totals, but sometimes you're forced to use this. Okay? And that shouldn't be that much of a problem. Lastly, if we wanted to just look at solving for resistances in series, and let's pretend we already knew what the total was. Okay, so here I'm going to look at just 2 resistances in series or in parallel with each other. If I gave you an R total of 20 ohms, okay, R1 was 40 ohms, okay, what is R2? How would we solve for that? We would go 1 over R2 is equal to 1 over R total minus 1 over R1. All right? Or in other words, 1 over 20 minus 1 over 40 would give us 1 over R2. And if you computed all that out, you will see that R2 equals 40 ohms. Okay? How did I do that, or how did I know that in my head? Well, there's also another trick you can look at. Lastly here. If you have 2, 3, or 4 branches that are all exactly the same amount of resistance in them, okay, you can take an individual total and divide it by the number of branches that are the same, and that'll give you the value. So in other words, we could go 40 divided by 2 will give me 20 ohms as an R total. We could change this up. Okay. Just do this. We're going to add, let's say 4 branches here, and let's say all 4 branches of these are 20 ohms. Okay? So that's 20, 20, 20, and 20. Okay? So, what do? We can go 20 divided by 4 to give me 5 ohms, or we could go 1 over 20 plus 1 over 20 plus 1 over 20 plus 1 over 20 to give me the reciprocal of that. And you will find that that also equals 5 ohms. Okay? The calculator function you're looking at for the reciprocal, do not get into the habit of going 1 divided by a number plus 1 divided by a number plus. No, you need to be looking for the calculator function that is x to the negative 1 or 1 over x. Those are your reciprocal button functions that you should look for on your calculator. Okay? Pretty straightforward. In the coming days, you'll be working on a lot of parallel circuit problems. We'll be giving you different values of information here or there, and you got to sort of solve the puzzle and fix it and finish it all up. Okay? Pay attention to the accuracy of your values. Pay attention to the rules that I outlined on the sideboard here, and you should be perfect. All right? So that'll end that lesson. Okay? Next one we will probably do, we'll talk about combination circuits. Thanks.